All right, guys, let's talk about lesson 2, which is balancing chemical reactions. First thing you need to understand when balancing a chemical equation is why you have to do it. That is because of the law of conservation of mass. Law of conservation of mass states that mass can neither be created nor destroyed, it'll just change forms. So, in our balanced chemical equations, in any reaction, there is a conservation of mass, energy, and charge. So that means that what goes in must come out. So that is equal to the number of atoms of each element must be equal on both sides of the equation. So however many of, say for example, carbon atoms you have on the left, you have to have the same number of carbon atoms on the right. So when we look at an unbalanced equation, it does not show the law of conservation of mass. So in this equation we have H2 plus O2 yielding H2O. And if we were to look at mass only, hydrogen has a mass of 1, there's 2 of them, so we have a total of 2 mass units here. Oxygen has a mass of 16 and there are 2 of them, so that's a mass of 32. 2 plus 32 is 34. That does not equal the mass of water, which is 18. So there is not a conservation of mass here. In a balanced chemical equation, that shows that there is a conservation of mass. The mass at the beginning is going to be the same as the mass at the end. So we have 2 grams of hydrogen, because each hydrogen is worth 1 and there's 2 of them, and we are also balancing it, and we have to have 2 hydrogen atoms. So we have 2 times the 2, which gives us 4 grams, plus O2, which has a mass of 32, 1 oxygen, 16 times 2 is 32, and that's going to be equal to 2 waters, because now when we balance this equation, we understand that in order for us to have the same amount of hydrogens on the left and on the right, we need to add an additional water atom. So instead of just having a 1 single water atom with 18 grams, we're now dealing with 2, which would be 36. So we have 36 grams on the left, and that is definitely equal to 36 grams on the right. So there are 5 steps for balancing chemical equations. The first is to total up the elements on each side first. Then you're going to start balancing and adding coefficients to the element that is only found once on either side of the equation. You want to keep your polyatomic ions together, so those big elements that form ions, you want to keep all of them together and you want to count them as a unit if they are not broken up. So for example, if nitrate NO3 is together on the left and on the right, you want to balance that as a whole and it will make your life a lot easier. Coefficients must be in the smallest whole number possible. So if when you balance, you end up that when you look at all your coefficients, they can be reduced, you have to do so. And then you're going to check each atom to see if it's balanced. So what's the easiest way for me to explain how to do it is to show you an example. So we have a single replacement reaction here where we have aluminum reacting with copper 2 chloride to produce copper and aluminum chloride. So the first thing you want to do is think of this equation as being split in half. Okay? So everything on the left-hand side are your reactants, what you're adding together, and everything on the right-hand side are your products or what's being produced. So we're going to total up the number of elements that we have on the left. We have 1 aluminum, 1 copper, 2 chlorines on the left. We have 1 aluminum, 1 copper, and 3 chlorines on the right. So what we're going to do is we're looking. Our aluminums are balanced. We have the same number of aluminums on each side. Our coppers are balanced because we have the same number of coppers on each side. Chlorine is what is not balanced on either side. On the left side we have 2, and on the right side we have 3. So we have to figure out how are we going to get these balanced. Now, just like in math class, when you add a coefficient in front of something, you have to multiply it all the way through. So what we're going to do is we're going to start balancing for chlorine. So we're going to put a 2 in front of AlCl3. That's going to be multiplied through, so it's going to change the amount of chlorines to 6 and the amount of aluminums to 2. Now, since that made our aluminums now unbalanced, let's balance for the aluminums. So we're going to put a 3 in front of copper 2 chloride. Again, we're trying to balance our chlorine atoms. So that makes chlorine 6 and copper 3. Now both our aluminums and coppers are uneven on either side, so we have to add coefficients to balance for those. So we're going to add a 2 to aluminum, and that balances our aluminum, and a 3 in front of copper, and that balances for copper. So now we have 2 aluminums on each side, 3 coppers on each side, and 6 chlorines on each side. So if we look at our coefficients, they're all in the least whole number ratio, so this is a good balanced equation. Let's look at another example. N2 plus H2 gives you NH3. Again, as always, split it in half. We have 2 N's on the left, 2 H's on the left. We have one N on the right and three H's on the right. How are we going to balance for this? So balance for the easier thing first. So the easiest thing to balance is to put a 2 in front of NH3 because that will give you 2 N's and 6 H's. So now our N's are balanced. Now we just have to balance our H's. What can we put in front of H2 so that we have 6 H's? That would be a 3, and that makes our H balanced. So this is a synthesis reaction with N's balanced and H's balanced. So that is a complete balanced equation. And our coefficients, the numbers in red, are at the lowest whole number ratio. So let's look at a practice problem. H2 plus O2 yields H2O. Pause the video, practice this on your own, and let's go through the answer when you're finished. All right, what did you get? So first, you have H2 plus O2 yields H2O. If you were to split this in half, how many of each would you have on either side? You start off with 2 hydrogens on the left, 2 oxygens on the left, 2 hydrogens on the right, and 1 oxygen on the right. The easiest thing for you to balance for is the O first. So we're going to put a 2 in front of water on the right-hand side. That's going to change our H's to 4 and our O's to 2. So now we have to balance for our H's. That's the only thing when we look on the left and on the right that's not balanced. So we're going to stick a 2 in front of the H2. That makes that H a number of 4 total. And so are we at the least whole number ratio? Yes. And we are now balanced. What about this practice? Try this on your own and unpause the video when you figured it out. Great, well, welcome back. So what did you come up with? When we split this in half, we start off with 1 Li, 2 O's, 2 Li's on the right, and 1 O on the right. So we have to balance for our O's first. So we're going to put a 2 in front of Li2O. That's going to make the number of lithiums 4 and the number of oxygens 2. So we have to come up with the correct number on the right-hand side. So we're going to have to put a 4 in front of Li on the right. That makes that number 4. And we're going to have to put a nothing in front of O2 because it's already balanced. And are we at the lowest whole number ratio for our coefficients? Absolutely. All right, let's look at this example. This example is a little trickier, but I wanted to show this to you because it has a polyatomic ion in it. It has nitrate in it. And notice how NO3 is together on the left and NO3 is together on the right. So when I do my tallies and I balance, I'm going to balance for NO3 as a group on the left and NO3 as a group on the right. So let's look. Okay, how many BAs do we have on the left? We have 1 BA, 2 CLs, 1 AG, and 1 NO3 grouping. On the right, we have 1 BA, 1 CL, 1 AG, and 2 NO3s on the right. Notice the little 2 outside parentheses that tells you how many nitrates you have. So we're going to start balancing. Okay, the easier thing to balance first would be to put a 2 in front of AgNO3 on the left. So that's going to change the number of silvers to 2 and the number of nitrates to 2. So now we have to balance on the right. So we're going to stick a 2 in front of AgCl. That's going to give us 2 Ags and 2 Cls. Now when we look, just by putting those the 2 in front of AgNO3 and the 2 in front of AgCl, everything else is balanced, so we're okay. So that is it. So now check your understandings. Balance the following equation, and we will talk about this in class tomorrow.